Okay, here we go, part 2. So what does that lead us to? Let's look at if we can move on here. Okay, so we're going to look at real quickly the parts we just talked about a second ago. So this symbol means integration. It means an integral. Um, that's the lower. So you always put the smallest or lower value at the bottom and the upper limit. So these are values of x. So where are you going to integrate from one number to the next? This would be the smallest. This would be the largest. Terminology, we would call this function the integrand. It might be a constant. It might involve variables. It could be logarithms, anything that you've seen so far. And then this is the variable of integration. It's sometimes called a dummy variable because it doesn't really depend upon the variable chosen. We'll talk about later how, will it ever matter, what letter we put here. Okay, so we need to talk about, we know what this kind of means now conceptually. Now how do we do it? That's what we need to talk about. So we're going to start by looking at our most basic functions, right? So we looked at something moving at a constant rate, okay? So constant rate, notice that we were moving at, what was the constant rate? 3 feet per second. And we're looking at after how many seconds? 4 seconds. So what's our distance? 12 feet. Notice that we get that by multiplying, but we also, right, visually it's the area because it's 3 units high and 4 units wide. It's just the area of that rectangle. How do I continue? There we go. So let's look at what if the velocity varies. So here we've got, right, just a slight differentiation. We have a slope of 1/2. That's our velocity. So we're velocity is going up. It's increasing. Now let's pause right here and look. How is this? First of all, what is this? It's the antiderivative. The S stands for position. Okay. And why is there 1/4 here? Yeah, so we're working backwards, and we know why does there have to be a 2 here? Yeah, it has to be one more than its derivative. And this t, where did it come from? The 1, right? 1 was the derivative of just t. Okay, so this is our antiderivative, and meaning that if we plug in a time to the first function, that gives us its velocity. If we plug in a time to the second function, it will give us the distance. Now, when we did the antiderivative, usually there could be a constant on this function. So like if this said +7, and I take the derivative, I'd still end up with exactly the same velocity. So right here, c is 0 since s is 0 at t equals 0. So in this example, we are taking the knowledge that we know that at time 0, we're starting at a position of 0. So that's something that could change in different application problems. Okay, 4 seconds. So notice that we do 1/4, 4 squared plus 4. We get 8. Oops, move that over there if I can. Okay. Now, any idea where this is coming from? What in the world's happening over here? We're looking at this area. If you're watching this video, looking at this area equals, where does this come from? I'll give you one hint. Think geometry. The area of this, what shape is this? What one shape is this? A what? Thank you, Gloria. You get credit in the video. It's a trapezoid. So this is the area formula from trapezoid, way back in geometry. It is 1/2 base 1 plus base 2 times height. Where do you see base 1? Where's this 1? Yeah, right there. Where's base 2? The other one, right? Where's the height? Right here on the bottom. You see that? So we can just use basic geometry. So sometimes you can calculate the integral just using basic geometry. I could just graph this. Oh, I know the bases and the height. It's going to equal 8. But we can also see that if I knew the antiderivative, I can come up with the same conclusion there.